By now, we learned how we can get data, how we can work with data and databases, how we can connect data with relations, and how we can use the admin panel to manage data. The problem is not all data will be managed or generated through that admin panel, because that admin panel is really meant for you as the developer, as the owner of this site, not for all your visitors. So you therefore also often need a way for your visitors to insert some data which you then might store in a database or somewhere else. You need to work with user input. You want to provide forms for your users, and that's therefore what we're going to dive in this course section. And not directly related to that, but still something I'll also cover in this section, will be class-based views. So that in this section, we will learn how we can create and handle forms outside of this admin panel. So now we're really talking about forms that are exposed to our website visitors. We're also going to have a look at different ways of handling those forms and how we can simplify that form management for us when working with Django. And then towards the end of this section, we're going to leave forms and go back to views and learn about an alternative way of creating views, an alternative to what we used thus far, an alternative that will make a lot of sense once we also had a look at forms and at handling user input. So let's dive right in. So for this course section, I got a brand new Django project created, the feedback project here. And in there, I now want to create a new app. So I'll do that with the same approach I always did, Python 3 manage py, start app. And then I'll give this app a name of reviews. Because this is just a dummy example again, of course. This little project and this app here specifically should be about accepting user feedback, in this case, accepting user reviews, where users can basically review some product we might have and leave some notes about it. And of course, for that, we're going to need to fetch some input from users. And we can't use the admin interface for this because this input should be entered by the visitors of our page directly on our page. The visitors of our page should not have access to our admin panel, which we might be using for administering whatever products we have on this page. In this example project, we'll have no products at all because I'll just focus on this reviews part and on this user input. So therefore, this is the new app created, and in this app folder, in this reviews app folder we just created, I'll then create my templates folder with a reviews folder inside of it, following this standard practice of, or this standard pattern of setting up my templates like this to utilize these Django app templates. And we're also going to add a URLs py file where we can then add the URL patterns list where we can register our URLs for this app. And of course, I want to keep this simple. Here, I really just want to have one view, one URL, one template, and that will be that view which allows users to enter data. So therefore here in URLs py, we want to import from Django URLs, and we want to import the path function here, and then define a new URL here with a path of nothing, let's say. And then we want to use a view, which we need to add in views py, and for the moment it's just a regular function, the review function, let's say. We're going to add the content of this function soon. And in URLs py, we can then import from this folder the views file and then access views.review. So now this is set up. Now in our project folder, in this feedback folder, in this feedback project, in the URLs py there, we want to import the include function from Django URLs and include our app-specific URLs. And hence here, we could route at them with a prefix of reviews or with the path of reviews, or instead say that we don't want to append anything after our domain, and then for this URL we want to load our review URLs, or this review URL in this case. And that's what I'll do with the include function. Then here I'll access reviews.urls. And here we're just applying what we did over and over again throughout the last course sections. With that, we got this view. Now let's add a template in the reviews folder, in the templates folder. And I'll name this template here review .html. And that will be my template for this view. And in there, I'll create this HTML5 structure. I won't even extend a base template here because for this simple demo, that is the only view I want for the moment. Hence, there's no need to extend anything. Of course, you could do that though. You could extend a main view if you wanted to. I'll give this a title of your review. And then here in the body, I want to do one main thing. I want to add a form where the visitors of our website can leave their review. And that's exactly what we're going to start with in the next lecture. So let's now start adding a form, a standard HTML form in this review HTML file. And then thereafter, we're going to make sure that this template also gets rendered by our view, which it currently isn't, and that we then also try to handle the form submission. But first of all, let's start with the form. For this, we create this form tag. We use the form tag, the default HTML form element. And then in such a form, we can output all the inputs we want to have in that form. So to start simple, we could add an input of type text, let's say, the default HTML input element. And that would allow users to enter some text. Now we can give this input a label to give the user a hint about the data the user should enter here. And there we could expect the user name. So we say your name. And it's also then considered a good practice for accessibility to connect label and input with special attributes in HTML and give the label a for attribute where you point at the ID of another element to which this label is related. So here we could point at an element with ID name and then give this input the ID name so that for screen readers, for example, it's clear that this label refers to this input element. We also want to give this input a name attribute. So here I picked name as an ID name. I could have picked anything. Maybe let's go with username to make that less confusing. So username it is here. But then the name attribute is a special attribute we can add to form elements like this input element. And this will then allow us to identify the submitted values once the form was submitted. And here I'll also use username as a value here, but we could use a different value than we did here. It doesn't have to be the same one. Now we have a form with one input element. We now also should add a button which can be pressed to submit the form. And here I'll then give this a caption of send. Now this is all just HTML, and if this is totally unclear, you definitely should revise those HTML basics. We're just creating an HTML form here. Now, before we do anything else here, before we add any other configuration, let's make sure that this template also gets served. So in the views.py file, here in the review function, I'll return render, and I accept my request here and pass that to render, and then point at the template which I want to render, which is reviews/review.html. So this template which we just worked on. And then save this file. And now with that, we're almost ready to start our server. First, I just want to go to my settings py file, and in there I want to add my app, my reviews app, so that Django will find the template here. That is important, otherwise this app template will not be discovered by Django. And this crashes because this should be path here, not include. So path in the URLs py file in the main feedback folder. Path, and then only use include here. Oversight from my side, with that fixed, now I can start that development server. And if we now visit localhost 8000, we get this very basic form here. Now it's lacking all styling, but it is a form. It also has this send button. And now watch the URL and see what happens if I click it. You see that? If I click send, the URL changes, and we got question mark username equals nothing. Now if I enter max here and I click send, the URL changes to question mark username equals max. So it looks like the data I entered here is then added to the URL. So let's now explore whether that is what we want, and let's talk about form submission and different HTTP methods. So we got this form in our HTML file, and that's a standard HTML form using standard HTML form elements. I have this button, and it looks like if I click this button that this form is submitted then. Because if I enter anything here, we see that it's cleared thereafter, and that data ends up in the URL. Now indeed, the page did reload. Whenever I click send, the page reloads, as you can tell by the flashing refresh icon if you watch closely. Now that's the default browser behavior. The default behavior we get when we add a form to a page and we have a button in the form that submits it. Now a button by default submits a form if placed inside of it, unless you give it a type of button. The default is type submit, and therefore you don't need to add this type unless you want to be very explicit about the fact that this will be the submitting button. But if we would set this button to type button, then if we save this and reload, you will notice that if I clear this URL manually, if I now click send, the page does not reload and we don't have this question mark thing appended to the URL, because now this button is no longer submitting the form. But of course we do want this button to submit the form. We want to use this button to take the user input and then do something with it, although we can't exactly tell yet what something is here. But still, let's turn it back to type submit, which, as I said, you could omit because that is the default anyways. But what does submitting a form mean now? It means that by default, the browser will construct a new HTTP request which is sent to the server that served this form. And without any extra configuration, that request will simply just be sent to your main server page, to your domain, so to say, and it will be a GET request. Now, what is a GET request, though? So this is how the web generally works. When we enter a URL in the browser address bar, a request is sent to this backend server. So to the server which runs our Django application and which serves back those template files or these rendered HTML files based on our templates. And our server might also be talking to a database. That's how the web works. Now, when it comes to sending that request, though, we, on the client, we can define with our code that runs in the browser which kind of request that should be. And the default, in many cases, especially if we don't configure anything in our HTML code, is that a GET request is sent. And that's one of the supported request types we can set. A GET request simply means I want to get some resource. I want to get some data. Therefore, if you enter a URL in the address bar of your browser, that will always send a GET request to the server. And we can see this back on our basic template here, on our basic page with this form. If we open the developer tools, which are built into the browser, in this case, Chrome's developer tools, and we go to the network tab here, if we reload, we see all the requests which are being sent. And that's only one request for this one HTML file here in the end, for this page. Now, if we click on this request, we see the response which was sent back, which is just that HTML code. But if we click on headers here in Chrome, we see some metadata for this request. And here we see the URL to which the request was sent, but we also see the request method. And we see that here the request method was GET. So this is one of the supported request types. And as I just said, if you just enter a URL here and hit enter or reload on an existing page, it will always be GET. That's the default because you want to get this page. You want to get this data, which is responsible for bringing this page to the screen. Now, if I click send here, a new request is sent also to the same URL, but with this question mark thing appended at the end, and it's also a GET request, as you can tell. So here again, a GET request is being sent. But where for visiting this page and for entering this URL for the first time, we are limited to a GET request, we can't change this there, we are not limited to a GET request when building our own forms. Here, we could change this. And we got a couple of alternative request types in theory, but with default HTML code as we're writing it without any JavaScript involved, there is just one main alternative, and that's a POST request. A POST request is the type of request you want to send when it's not primarily about getting back data, but if it's instead about submitting data to the server. So if you, that's a typical example, fetch user data in a form and you want to send this to a server, then you could send it as a GET request to imply that you mostly want to get some new data, but you typically would instead use a POST request to make it clear that you collected some user data and you now want to submit that data to the server. Now, if you don't set it to a POST request, and we will set it to one in a second, then as you saw, if I click send again, a GET request is sent by default. And for a GET request, the entered data in the form is added as so-called query parameters to your URL. That's this question mark thing. These are query parameters. It's data encoded in the URL. They are optional, but they always come after such a question mark if you add them. And then you simply add them as key value pairs with the key, equal sign, and then a possible value, like for example, max, which I can submit. Now that's our key value pair here. Now these are query parameters, and we could extract and read those on the server side as well. But as mentioned, you typically instead want to send a POST request to make it really clear that you are submitting data, that this request is not primarily about getting data. And when you submit a form, of course, it's typically primarily about sending data. Hence, back in our code, we might want to change this form to send a POST request. We want to tell the browser to send a POST request instead of a GET request. Now, to send a POST request here, we go to our form HTML element and we add an attribute here. To be precise, the method attribute. With that, we configure the HTTP method that should be used, and the default is GET, so we don't need to set this, but now we want to set this to POST, which is the alternative. And this will then send a POST request when this form is submitted. Now, if I save it like this, and we reload our page here, If I now enter Maximilian and I click send, you'll notice something interesting. Now I'm getting an error here, a CSRF error. I'll come back to that in a second. But if we have a look at the request which it tried to send, we see that the URL still contains the question mark, but only because I didn't clear it before. So if I do that, if I clear that URL and I click send, we see that indeed this is now not added, this question mark thing. And the request method is post now. And the data which is submitted is now no longer encoded in the URL with those query parameters. Instead, if we scroll down, there is this form data. A post request, unlike a GET request, can carry data. It has a so-called request body, which is an extra data package attached to your outgoing request, which contains data. In this case, this form data about the data we entered in the form, where we also have key value pairs with a key of username, because we picked username as a name on this input. Whatever you pick as a name here will be your key, and then the value entered by the user. And that data is now sent to the server where we can use it. But before we can use it, we need to fix this error, this CSRF error. Now, where's that coming from? CSRF stands for cross-site request forgery, and it's about building requests that look like valid requests but actually aren't. Now, what does this mean? Let's go back to our page here. We have this form, and this form is rendered by our website. Now, let's say this form would not be about getting the username, but about filling out the details for a bank transaction, for sending money to someone else. Now, if I'm a bad guy, I could rebuild the look and feel of the official form from a bank, but host it on my own site, possibly with a URL and a domain that looks very similar to the official bank's domain. Now I could trick users to visit my page, for example with some phishing emails which I send out, and once they're on my page, the page to them looks like the official bank's page, and they might fill in the details to send money to a friend. But since it's my page and I'm a bad guy, actually I might gather some user data, but then send that data slightly modified to the original bank's servers. I might, for example, replace the name and the bank account number of the recipient with my name and my bank account number. So in the form, users don't see that, but I do that behind the scenes, so to say. And there are ways of achieving that. Then this request for sending money gets sent to the bank's official servers, and all of a sudden, people start sending me money instead of their friends. That's how I could forge a request, how I could fake a request, how I could build a malicious request. This is a common and popular attack pattern, and Django protects you against it with something that is called a CSRF token, a token that prevents this attack pattern. Now, how does it work? The idea basically is that in our website, in our web application, which we're building, we add a dynamically generated token to our generated forms, and that token then has to be sent together with the post request to our servers. If someone then fakes our site and builds his or her own form sending fake or manipulated data, that token will be missing because only the official server, our application knows how to build that token and how a valid token should look like, because that token is generated on the server. So therefore, only we are able to build forms that include a valid token, and attackers are not. And on every incoming request, we then check whether such a valid token is part of the request, and we only accept the request and do something with the data if it is. Now, at the moment, our form which we built here doesn't include such a token, which is why when I click send, we get this error. that the CSRF verification failed because this CSRF token, which we should add, is missing. To fix it, we want to insert this token, which is generated by Django, into our form. And doing so is simple. We just need to add a special tag here in the template, and that's the CSRF token tag, which looks like this. By adding this instruction in your Django template, Django will go ahead, generate this unique token and add it in that form, and then validate that token once your post request arrives back on the server. So if we add this and save this, if we now revisit localhost 8000, if we have a look at the Elements tab in the Developer Tools, we see that in this form there is a new input, which is hidden and therefore not visible because it's not an input where the user should enter data, but instead it is an input with the name of CSRF middleware token and this cryptic value here. And that's this token which is generated by our Django backend, by our Django application. Now, if we would send this request, if we would send this form, it would succeed because that is a valid token which is accepted by our server. But if someone fakes our form, they can't know this token. The token also won't be the same all the time. It will change every time we load this page. And therefore, only our template rendered by our site will have that valid token. So attackers won't be able to send fake requests to our server. They can send requests, but we won't accept those requests because they are missing a valid CSRF token. So that's a security mechanism built into Django. So now with that, if I send Max again, now this succeeds. And now if we visit the Network tab, we see that a post request was sent. Currently, though, we're not doing anything with that post request on the server. So that's the next step, the next thing we want to do. We want to make sure that we don't just do nothing, but that instead now we read that submitted data, specifically the username, on the server and then maybe do something with it there. So how can we now utilize that submitted data? Well, for that, let's go to Views PY, because that is ultimately the place where this incoming request is handled. You might have noticed that a request was sent successfully and we didn't get any error once we added the CSRF token. Now, the reason for that is that this request URL for this post request was actually localhost 8000/nothing. So it was that same URL we use for loading this page. If I enter localhost 8000 in the browser, we send a request to the same URL. It's just a GET request, but it's always the same URL. Now, because that's the case, we always hit this path here in the end in our reviews app, and therefore we ultimately end up in this view function, and there we always render this template. So this view function gets triggered for both a post and a GET request, and that is not uncommon. Though to make it clear, you could also change the URL to which your post request is sent. Back in the template on the form, besides adding a method, you can also add an action. And this allows you to specify the path after your domain to which this request should be sent. Now, if I set it to /nothing, it will be that standard URL, that main domain URL to which it already is being sent. But if I set it, for example, to /user_review and save this, then if I reload this page and enter Max and click send, then we would get a page not found error because now the request is sent to our domain /user_review. So you can change that URL to which the request is being sent. It's still a post request, but now also sent to a different URL. But here I don't want to change it. Hence I'll set it to /nothing, and I could even omit it, as you saw before. But to be very clear, I will add the action attribute, but send it to /nothing. And therefore it will arrive in this view function. So now in this view function, we actually want to check whether we get a post or a GET request, and then do different things based on that request type that request method. So we get a post and a get request, two different kinds of requests in the same view function. And as I mentioned, this is not uncommon or bad. But typically, we want to do different things based on the request method. We might not always want to render our template. Instead, if a post request is received, we might want to read that post request and then do something with that. We might want to read the submitted data, store it in a database, or do something like this, and then send back a page, possibly a different page than we do for a GET request. Because for a GET request, I want to send back that review template. Maybe for a POST request, once we read the data and did something with it, we want to send back a different page. Maybe then we want to send back a thank you page. Hence, I'll add a thank you template, rebuild my skeleton. And yes, we could extend a base template for this, but I'll keep it simple and just duplicate it here. And then there simply say thank you. So that could be the page, the template, which we want to render for a successful post request. Now to do that, we need to add an if check in our view function. And we need to check the request, so this request object which we get, method. This request object which we get here has a method property which tells us about the HTTP method which was used for this request. So in our case, if it's a GET or a POST request. And we'll get this method identifier as a string. So here I can check if the request method is POST and then do something, and only else do something else and return this rendered template. Now, what do I want to do if it is a POST request though? Well, then I might want to extract the data which I receive on that request. So here I might want to get the entered username, and we can get access to the data by accessing request again to read some data from the request. And now the post key. So method gives us access to the method that was used for submitting the data. .post gives us access to the data itself. To be precise, post will hold a dictionary where the keys are the names set on the inputs in the form, and the values are the entered values. So here I can get access to a username key on that dictionary because I have a username input named username in my form. And that will be that entered username. Now here I'll just print it for the moment. We could of course store it to the database through a model, or we could write it to a file, but I'll just print it here. And then thereafter we might wanna render this template here, this thank you template. Now we can of course do this by returning a different render result here inside of this if block, and here return reviews/thankyou.html. That's something we could do. But typically, we don't wanna send back HTML code as a response for a post request. Because a post request is meant to submit data to the server, not to get some page. Therefore, what we typically do upon a post request is instead of returning a rendered template, we redirect to a different URL with a GET request, and that different URL will then render a template. So for that, I'll add a second view function here. Let's name it thank you maybe, where I get a request. And here I will then return this rendered template. Now we just need to register a URL for that. So I'll add a path of, let's say, thank you, and there point at this thank you view. So I did that in URLs py in my reviews app folder. With that, we have that thank you view and URL. And now here in this if case, in the review view, in the post branch, so to say, I want to redirect at this URL so that the URL in the browser bar changes and we switch from a post back to a GET request. This is not technically required. We could render the template here, but it is better. It also ensures that if users reload that thank you page thereafter, they don't get this box where they're asked if they want to resubmit data, because the page was loaded with a post request originally, but instead it smoothly reloads. Hence here, we can now return a redirect. And we do that by importing from Django HTTP our HTTP response redirect. And we then here return HTTP response redirect. And to that constructor function, which we're calling here, I pass /thank you to redirect to my domain /thank you. And again, this will then result in a brand new request being sent, a GET request specifically, which then will ultimately reach this view here and lead to this thank you template being sent back. So with all those changes in place, we are now extracting the incoming data, we're printing it, and we are redirecting to a new URL and view. If we save all of that, we can give this a try. And we go back to just localhost 8000 here. And if I now enter Maximilian here and click send, I see thank you thereafter, and the URL changed to thank you. We see that 2 requests were sent, a post request to localhost 8000, where the status code is 302, which is a redirection status code. And then thank you is another request which was sent, which is this get request to thank you, which is sent because of our redirection. And if we go back to the server, we see Maximilian here in the log. And that's coming from this print statement, because we successfully extracted that data. And of course, logging it to the console is just some dummy solution here so that we can see that it worked. In reality, we might want to store this to a database. And we're going to do so throughout this module. But before we do that, I want to dive into a couple of gotchas with our current request where we manually build this form and all the inputs. So now we know how to create a form, how to control how and where it's submitted to. We learned about the CSRF token, and we're able to then do different things in one and the same view function and return this redirect if we have a post request, and there also get our data extracted and then do with it whatever we want. Now, before we do more with that data, before we, for example, store it to a database, let's come back to that form handling in general. At the moment, I'm extracting data and I'm printing it. In reality, you typically also want to validate a form. You want to check that what the user entered is valid. Because, for example, at the moment, if I go back to just localhost 8000, if I submit this empty form, so without entering anything here, that still works. I still make it to the thank you page, and here in the terminal we see that nothing was output there for this print statement because entered username is empty because it was submitted in an empty state. Now, we can't fully avoid that users might submit an empty form, but we therefore typically want and should validate it on the server. We want to validate the user input and make sure that, for example, username is not empty. Now, of course, we could add another nested if check for this and check if entered username is equal to an empty string. And if that's the case, we might want to not redirect and not print it, but instead we might want to, in that case, render this review template again. So that for a post request, we do render this again, but we do so because we want to present the same form the user submitted again to the user to allow the user to update his or her choices, to update the data. And for that, we might want to not just render the form like this, but instead maybe with some extra context passed to the template, where we have a has error key, which we set to true. And normally we might want to set this to false. so that normally for a GET request, we have has error and set this to false. But if we did have a POST request but have invalid data, we render the template again with has error set to true. And then we can go to our review HTML template, and here we could then simply check if has error, so if that is true, and then of course also have end if here. And if we have an error, we could show a paragraph where we say, this form is invalid, please enter a valid username. And if we update our form like this, then we added some basic validation, because now we don't use the entered username if it is empty, and we don't redirect to the thank you page. Instead, we return the same form template again, but with this has error flag set to true. And hence now, if we reload and submit an empty form, we now get this form is invalid. And only if I enter something valid, we make it to the thank you page. And validation like this is something which we typically want to add. But it also means that we now have a lot of extra work to do. This is a basic form with just one input field, and I'm only checking for this input field to not be empty. In reality, you might have a longer form with more input fields, and for your input fields, you might also have multiple conditions. For example, that username should not be empty, but also not longer than 100 characters, or something like this. And therefore, you would have to check for all those things in your view here. You have to check for entered username not to be empty, and to have a length that is, for example, smaller than 100. So if it's greater than or equal than 100, you also want to return this. And you also might want to update your form and show different error messages here in your template based on how the validation failed. If it failed because the username was empty or too long, or because you have some other field which is invalid. So all of a sudden, handling a form manually results in a lot of work. And it results in a lot of work, which then typically is the same across all the forms you have in your project, in your different templates. Because for all the forms you might have in different places, you always want to render the form with labels and your different HTML control elements. You then always might want to show error messages if something failed, and you always want to validate your received values based on typically the same rules, maybe just fine-tuned regarding the max length or something like this. And because this is such a common and repetitive task, with Django, you don't have to do that manually. You can do it all manually, as shown in the last lectures and this lecture, but you don't have to. Therefore, let's now dive into the Django Form class and how that class helps us construct forms, validate forms, and use form data. So let's explore the built-in Django Forms support. For this, let's add a new file in our app folder, so in the reviews folder, and let's name it forms.py. The name is up to you, and you technically don't have to generate a new file, but that is a common pattern to do so. Now, in this file, we're going to create a class that defines the shape of our form and the different inputs we want and the validation rules for those inputs. And we'll then be able to automatically render that form in a template and to automatically let Django validate that form for us. So for this, we create a new class here, and the name is up to you in general. I will name it review form, and it's kind of a convention that it ends with form, but technically that's not required. Now, what is important and what is required to utilize Django's form features is that we do extend the built-in form class Django ships with. For that, we import from Django, so just from Django, no sub-module, we import forms like this. And then here we extend forms.form with our review form here, like this. Now in this class, which we're building here, we can define the different form fields we want to have. Now that's kind of similar to the model fields we had before in the earlier modules related to defining a model. But now with this form class, we're not defining any database model. This will not have any impact on the database like this. Instead, we're just defining the shape of a form with the different input fields it might offer. And some of these fields will be very similar to model fields, as you will see, but some model fields will also not be available as form fields. But in general, a high similarity makes sense because very often you will want to fetch data for a model with help of a form. So it makes sense that there are some similarities, as you will see. But let's see it, and therefore let's create or let's recreate this form which we had here with our custom form class. So for this, in the review form, we can define a user underscore name field, for example, and this name is up to you. And now set this equal to forms.char field, for example. And again, that's the similarity to the models. There we had models.char field, if you recall, and that would create a text field in the model and in the database. Now we have forms.char field, and that will not have any impact on the database, but it will later create a text input field in the form, which we're going to render. So we can add such a char field like this, and in its simplest form, we can leave it like this and have this basic form which we're defining here. Now let's go to our views.py file and get a hold of that form there. So therefore we can import from .forms, so from this forms file in this folder, we can import this review form class which we defined there. And now here in our review view, I will change how we render this. I will comment out this post part for the moment, and instead, below that, before we return the rendered result, I will create a new form variable, though that variable name is also up to you, and instantiate a review form like this without passing any data to it. So the constructor here stays empty. This argument list stays empty. I don't pass any data to the constructor. I instantiate it like this. And then when we render the template, instead of passing has error here, which we won't need anymore, I pass a key named form. This key name is also up to you. And I point at the form stored in this form variable. So I pass this created form through the form key here to my template. And now in the template, we can replace the label and the input, not the whole form, just the label and the inputs we might have there, with form being output like this. So with this form variable, which we're setting here, which holds our form, just being output like this. And this will render a couple of inputs and their labels automatically based on the form definition in our class. Now we can and now should also get rid of this if check here, and we should still keep our CSRF token. So that's how our form should look like now. A form element with our action and method, the CSRF token, then the form controls in the end, which will be rendered here, and then our button. Of course, we could switch the order here, but typically you want to have the button after the controls. Now with that, if we save this, if I go back to localhost 8000, I have this form, which looks very similar to the form from before. But this actually was now automatically rendered by Django based on our form class. And if we inspect it here, we see that indeed it is a different form. The input, for example, has the required attribute. The name is now user underscore name. Before, for our own form, it was username in one word. And the label is also user whitespace name, not your name as we had it before. And the ID also is a different one. So this is definitely not the HTML content we wrote before, but it's automatically generated HTML content by Django. And that's of course very convenient, because now we don't have to write all those controls, which can be very cumbersome for longer forms, but we can rely on Django for it to output this form to us. But even better than that, we can also use Django's built-in validation. Back in views py, we can comment this request method equals post check back in, and now we don't have to extract data manually anymore. We can get rid of that. We don't have to validate data manually anymore. Instead, we now can also create our form here. And now set this equal to review form, as I did it down there. But here in this post block, we can pass request.post to the review form constructor. And keep in mind, post was that collected data, which is part of the post request. Now that data will be the data the user entered in the form. So now we're passing that entered data into review form. And what this allows us to do now is it allows us to call form.isValid, a method which exists on this form class because it's a method defined in this form class we're inheriting from. So we can call isValid now, and isValid will do 3 things for us. It will go ahead and validate the inputs, and for example, by default, it requires them all to be required. It requires them to not be empty. So it will check whether what the user entered for a username is not empty. Then, if the form as a whole is valid, it will return true here. Otherwise, it will return false. And last but not least, if the data is valid, it will populate another field with that valid data. So here, if form is valid, then I want to print form.cleaned data, which is the field that will contain that cleaned validated data automatically. So that's another field which exists on the form, just like isValid exists, because we're inheriting from the form provided by Django. And then I redirect. If we don't make it into this if block, we would recreate the form and re-render the template. So let's see this in action. If I save that, if I reload this page, if I enter nothing here, I now automatically get this error actually, because of this required attribute, which tells the browser to already pre-validate our inputs. That's nice to have to avoid that the invalid form is being submitted, but you shouldn't rely on just that, because in the developer tools, I can, for example, delete required, as I did it here, and now I can submit the empty form. But then you see we again end up on this form page, because we do render that if we don't make it into this isValid block. That's where we would redirect, but we don't make it in there if the form is not valid. And this server-side validation is nothing we could circumvent on the client. If I do enter something valid here though, then I make it to the thank you page. And then here in the console, we see this dictionary, which is being output here. And that's this cleaned data, which is a dictionary with the keys, which are our field names in the form class, and then the values entered by the user. And then we could use that data to submit it to a database, write it to a file, or do whatever we want to do. So that's how we can use the built-in form object. But we can do even more with it. For example, we can conveniently show error messages in the form here if we submit it in an invalid state. We are already taking advantage of a lot of the pre-built helper functionalities Django gives us when it comes to working with forms. We are using the built-in validation helper here, but what we're not doing is showing the user errors that might have been generated. And we're not doing this because if we don't make it into this isValid block, we always generate a brand new form and render that with our template. And that will be a brand new form without any data from the old form. What we want to do instead is use our validated form, on which we called isValid, and render that instead if it is not valid. Now, to achieve this, we simply have to add an else block here to this first if statement, where we check if the request method is post. And if it's not post, then we'll create a new empty form. By doing that, we will always end with rendering if we have a post request but are not valid, or we have a get request, but we only create a new empty form if we have a get request. If we have an invalid post request, so a post request with invalid data, then we'll make it into this part of the if statement. We're going to fill this form class with the submitted data. We're then going to validate it. And if it's invalid, we'll not make it in here, but instead move to this line. But the form we pass to the template now is the validated form. And we can see the result if we save this and now try to submit an empty form again. For that, let me remove required here and clear this. And if I now submit this, now I get the same form again, but I get this nice error message being shown here. Now, by the way, we will of course be able to work on the styling. We can add our own CSS still. I'm not caring about styling here because I really want to focus on the core form functionalities Django offers us. But we are going to add some styling later. So now we see that the form that was rendered contains an unordered list right above the input below the label for which the error was shown. And that list then actually lists all the error messages that were thrown, which of course is very convenient and useful because this then automatically gives us some predefined error messages, which we then also show to the users. In addition, any data which might have been entered into this form already by the user would not be lost. Of course, here it's an empty form, so no data was entered, no data is saved. But if this would be a bigger form where a couple of fields have already been filled out and then validation for some other fields failed, in such cases, when this form is being presented again with those validation errors, any previous input by the user would have been saved and would have been presented again as well, so that we provide the best possible experience to our user and we don't force users to re-enter everything. So that's another neat feature. We get these validation errors and any previously entered data would also be saved and would have been pre-populated into that form, thanks to us using this Django form and passing in the data received by the user before rendering this template again. But speaking of predefined, there are a couple of predefined behaviors here, for example, the label text or the error messages, which we might want to overwrite. And thankfully, we can do that. As with pretty much all aspects of Django, we can configure this form behavior and how the form is rendered and which label is showing up here and so on. We can configure this as well. For this, we just need to go to our code and then to the forms.py file where we define the form. And then for this username field here, we can set a couple of options. We can add a couple of keyword arguments that allow us to configure this field and therefore this field's behavior in the template. For example, there is a label option where we can set our own label. By default, Django will use our field name, capitalize the first word, and replace underscores with white space, which is why we see username like this here. But if we want to show your name instead, then we just can set label like this. And if I now save this and reload this page, now we see your name here. So that is one basic thing we can configure. For the char field, we can, for example, also add a max length argument to restrict the maximum length and set this to 100 characters. If we do that and save this, if we inspect this input, we see the max length attribute was added here. And even if I manually remove this to circumvent this validation, if I now enter something super long, which is longer than 100 characters, so if I enter a very long dummy string here and I click send, then I get an error message because this is being validated on the server again, because of this max length argument I added. Now maybe we're also not happy with the error messages. And for that, we can add an error messages key here and set this to a dictionary where the key names are the validator identifiers Django knows, and the values are then the error messages for those kind of errors. So for example, all form fields, including the char field, by default have the required validator. And if we submit an empty field, it's the required error message that will be shown. We can override this by setting required here to your name must not be empty, for example. Then we could also set the max length error message and say, please enter a shorter name. Like this. And now we would have our own error messages. If you want to allow the submission of an empty field, for example, you could set required to false. The default is true, so by default that field is treated as required. But if it's optional, you could set it to false. But since I want to show you these custom error messages in action, I will remove that or set it to true. But again, that's the default, so I'll remove that so that we do require that field. And with that change made, now here, if I manually disable this max length attribute and the required attribute to ensure that I can work my way around this browser-side validation and submit the empty form, if I do this and click send, now I see my custom error message here. And if I submit it in an empty state after removing required, then I see my custom error message here as well. So that's how we can customize this. But we're also not limited to customizing our messages and labels. Now, as always, if you want to learn about all the options, the official docs are your friend. And there it's the form fields reference which you might want to check out. Here you'll learn about all the different methods and arguments which you can set on a form field, like required, which you just saw, or the label, and also a couple of other values which might come in handy for you from time to time. Here you also see all the possible form fields you can create besides the char field, but we're also going to see more options there soon, so I'm not going to go through that list yet. I of course just want to make you aware of it so that you know this resource for your next project. But now let's dive into how we can customize what is being rendered where instead of just customizing these texts which are being output. At the moment in our form, we render the whole form, so not the form element actually, but all the form controls, like this. And we use Django's default way of outputting the labels and the input elements and the errors. And therefore, for example, it looks like this. We got a label, then the list of error messages, and then we got the input field. Now, maybe we want to change this. What if we, for example, want to render the errors below the input field instead of between the label and the input field? How could we achieve that? For this, we can dive into our template, and instead of rendering the form as a whole here, we can render the individual parts of our form. So for example, still with the double curly braces, we can start with outputting our label. For this, we access our form, But then with the dot notation, we dive into one of our fields. In this case, the only field we have, the username field. So form.username. And then we want to output the label of that username. And we do this with the label underscore tag field here. This will render the label. Then below that, we might want the actual input element, which we render with just form.username. So just the field itself without any nested property. So this will render the input element itself. And if we want to render the errors below that, then we can do so by accessing form.user_name.errors. And now we'll switch that order for that field. And we would have to do that for all the fields of our form now. It's either the entire form being rendered or everything being customized, but I will show you ways of speeding that up and making that more convenient later once we have more than one field. At the moment, the username field is the only field we have, and therefore this is perfectly fine. If we now do that and reload here, you see we now have label, input, and then the error messages. So now we have that order specified in our template. Now that we know that we don't have to render a form as a whole, we can of course customize it even more, and we have even more influence on how things are going to be output. For example, we might want to wrap every form control, so like the input element and its label and its errors, into a div for styling purposes with a certain CSS class. So where we add a class of form-control, for example, which at the moment doesn't add any styling, but which we could use to apply some styling. And then different form controls would live in different divs. We also might want to add a CSS class dynamically here when that input is invalid. A CSS class which we could then use to, for example, give the input a red border. For that, we might want to add an invalid class to this surrounding div if the input in there is invalid. And we can do this with an if tag, for example, here. So here we can add an if tag and check if form.username.errors. This will return true if it's not an empty object in the end. So if this is a dictionary with error messages inside, if that is the case, then I add the errors class here, and then I end if. So I'm using that if tag now inside of my class list for this div, but therefore this errors class will only be added if we do have errors. And with that adjustment made, if I save that and reload, now we have this extra div wrapped around our inputs, and it does have this error class. If I visit localhost 8000 like this instead of reloading though, and I therefore have the empty valid form initially, then we see this errors class is not there on this class list. And at the moment we're not utilizing any CSS classes for styling. We're going to do that soon, but we could use it. And this shows you how you can still fine-tune how your controls and your inputs are being labeled, are being output, and how they might be styled therefore, whilst still utilizing the built-in form support by Django, for example, for this convenient validation. And now with all of that in place, let's actually add some styling and then a second input. So let's add some styling, and for that I'll simply add a static folder in my app folder, and then there add the reviews subfolder as you learned it, and here I'll add a styles CSS file. And I want to keep this relatively simple. I just want to give this form some basic styling. For this, I'll select the body and give this generally a font family of sans serif, since I prefer that look. And I'll remove the margin on the body, which we have by default. And I'll select the form element and give that a margin of free rem auto. And a width of 90%, but a max width of 40 rem, which will be centered because of margin auto here to the left and right. give it a padding of 1 rem, a border radius of 12 pixels, and a background color of white, and then a box shadow of 0, 2 pixels, 8 pixels, RGBA 0, 0, 0, 0.26. And that's just some styling I'm coming up with here. Now I want to give the button some styling as well. Set the cursor to pointer, give it a padding of 0.5 rem and 1.5 rem, give it a border radius of 12 pixels, and give it a background color of purple, which I'll use as a basis to pick a different color. Let's say this blue purplish, this dark blue purple. Give it a text color of white and a border of 1 pixel solid and that same color as I use for the background. And then maybe also define a hover and an active style for the button where I set the background color to that purple color, but then pick a little bit of a lighter shade of that. And the same for the border color, set that to that same lighter shade. Now let's just make sure we also import the styles CSS file. And therefore let's go to review HTML, and here below the title, I'll add a link where I set rel to style sheet, and then set ref at this dynamically generated import. So here we use static and then point at reviews/styles CSS to use this styles CSS file in the reviews folder in the static folder. For that, we need to unlock this static feature, which we do with load static at the top. With that, let's quit and restart our server so that these static files are picked up now that we added them for the first time. And now I got this look here. Actually, let me tweak this a little bit and change the border radius of the button to 6 pixels. And for the form, I'll set the max width to 30 rem. And this now looks better. And now let's work on the input. And for this, we can utilize this form control div, which we wrapped around our form elements, our input elements. And therefore here, I'll now access form-control, this class, which we added to that div, and give that a margin to the bottom of, let's say, 1 rem. And then also use form control and select any inputs in there to give them a font where I inherit the base font so that they use the same font family as on the rest of the page. Give them a padding of 0.25 rem in all directions. Maybe a border radius, border radius of 4 pixels for slightly rounded corners. And set a border of 1 pixel solid and a slight gray color. And then also work on the focus style of those inputs. So when they are focused, to change the border color then to, let's say, our dark purple color. Set outline to none. And set the background color to a very light version of our purple color. So a very, very light version like this. Also on input, I want to set display to block so that they take up the entire line, and set width to, let's say, 10 rem here. Let's see if that works. And then also target form control label and maybe give them a font weight of bold to make them bold, and also set display to block here. And you find these finished styles also attached to this lecture. With that, if we reload, that's how our form looks like now. Now, of course, you can tweak this in whatever way you want, but I'd say it doesn't look too bad. And what we can do now is we can now also style our errors. So that if I remove that required attribute here, so that we disable the built-in browser validation, and I submit this empty form, we now also change the styling of the input and the label if we have an error here, and we also change how our errors are being shown. For this, let's go back to CSS, and on the label, first of all, I'll add a margin bottom of 0.5 rem. And then I want to target my error-specific classes. For this, again, let's note that here in the rendered HTML content, we have an error list class on the rendered list of errors. That's a default class Django adds there, and you could customize this as well with some settings in the forms py file. Here, besides setting those error messages, you can also set the error class, which is added on this list of errors, but I'm happy with the default. So we have this error list class on that rendered list, and don't forget, we also manually add errors to our class on that wrapping div. So these are two classes which we can now use for styling. And let's start with the error list on that unordered list. There I'll set the list style to none to disable the bullets, set margin and padding to 0, and important, give that a color of red. To be precise, let's pick a little bit of a nicer red, maybe some dark red color like this. And I'll also select errors, which is that extra class we add on the form control div if there is an error in that affected input. And I then want to target any input in a div that has the errors class and give that a border color of that red color we used here, like this, and give it a background color of a very light red version, something like this. And I'll also target the label and change the label color also to this red color if we have an error on that input. And with those classes added, if I now reload, you see this is red, this has this red background and a slight red border, and this text is also red. And maybe some spacing would be nice between input and this error list, and therefore on the error list, I'll set margin not to 0, but to 0.5 rem, to top and bottom. And with that, this looks nicer. So now we have this output here. Now we do have some styling added, and of course you can tweak this to your requirements, but now we know how we can utilize the form class and still customize it a lot. But of course, at the moment, we still only have one form field, and it's definitely time to change this now and to dive into other fields and learn how we can render those as well. So let's add more fields to that form. It should be a review form, so besides the username, it makes sense that we also want to get the actual text of the review, the text the user enters us, the feedback, and maybe also a rating between 1 and 5. So for this, I'll add a review text field here and set this to forms.char field as well. Give it a label of your feedback, let's say, and now I also want to control which kind of HTML element is being rendered. For the char field, it was an input element of type text, which works out just fine. But for the feedback text, I actually want to render a text area instead of a char field. And thankfully that is possible. All we gotta do is go to this char field and then there add the widget parameter and set this to forms.textArea. And this will then render a text area instead of this text input. And the text area is there to allow us to enter longer text. Now we also might want to set a max length here and set this to 200 so that no more than 200 characters can be entered. And we're good. Now we also want to add a rating field. So for that, we can add a rating property to our class and set this to forms.integer field. which is another supported form field. Again, you can find all the supported fields in the official docs. We could set the label to your rating and then set a min value here, not length, because here it's not about some text, but about a number that should be entered, and set a min value of 1 and a max value of 5, so that the rating has to be a number between 1 and 5. And now we have these fields as well. Now, if we save that and reload, or revisit localhost 8000, we don't see those fields though. And we don't see them because we manually render our form fields. We manually render the username field. If we would have used form, then everything would be showing up. So if I temporarily re-add that, now we see everything being rendered. Of course, my name or your name is being rendered twice now because we output it manually and then we output the entire form. But I want to render it manually because I want to have that wrapping div. So therefore, what we need to do here is we need to grab that div, duplicate it, and then simply access form.review text here, which is that second field we have, review text. Access that and access the label, and repeat that for the field itself and for the errors. And also use form.reviewText here in our if check. And now we would also, if we reload, render this feedback box. We can do the same for the rating. So here we repeat this again, and then here we output form.rating, and here and here. And now we also have that rating field here, which, as you see, is automatically rendered as a number field between 1 and 5. But of course, now we're manually repeating this. And whilst this is possible, it's not necessarily the most convenient way of outputting our form inputs manually. Because we, of course, repeat the same kind of HTML code over and over again. And that's not typically what we want to do here. So it would be great if we wouldn't have to repeat this all the time. And that is something we can do with the for tag, with a for loop in the template. We want to loop through all the fields of a form and then output this div for every field. For this, we can write for field in form. Field is up to you, form is not. That's our form variable, which we expose to this template. And then we also have end for. And now inside of this for loop, we repeat this div here. So we output this div here in our for loop. This div is repeated for every field in the form. And now we just need to use field instead of form.username and what we had before. Because this will now be repeated for every field in the form. So now it's just field.label tag and just the field itself, and then also just field.errors. And we could even outsource this div block into an included HTML file if we wanted to move it out of this file entirely. And then just repeat that included HTML snippet in this for loop. But here I'm fine with having the entire HTML structure. With that, we can get rid of these divs down there. And now we have a very lean template where we go through all the fields in the form and recreate that div with the input, with the label, with the errors for every field. And if we now save this and reload, we still have all the fields being rendered, but now with less code in our template, which is of course what we want. And with that, we can now fill in some text here, my feedback to you, give this a rating and send this, and it works. And all that data is collected and usable on our backend, in our view code. What's being printed in the console here is still coming from this print statement. So we didn't have to change anything about our view function here, even though we edited the form and we now have more form fields. because the validation still happens automatically and the data is also still automatically extracted and stored in this cleaned data field, which gives us such a dictionary. And that's how easy it is to add more fields to a form. Now, as I mentioned before, in the official documentation, you can learn about all the built-in form fields. There are also form fields for rendering dropdowns or checkboxes, and that's all up to you. But you will always add them in exactly the same way as shown here, as new properties to your form class. Then you pick the proper Django form field you want to render, you configure it as needed, and then you output it as shown here. And you can then tweak and customize it just as you need it with the different approaches and concepts I showed you over the last lectures. So now we got a form with multiple fields, we added some custom styling, and we also make sure that we can validate the input data, but that we can also use it eventually in our view, and at the moment we're just printing it. Now it would be more realistic that we of course want to store it in a database. And therefore let's add a model. So in the models py file, I'll add a model as we learned it before in the course. I'll add a new class, name it review, and extend models.model here, and then add any fields we want. For example, the user name field, which is then a char field, now from models, not from forms, but from models, which then sets up a char field, a text field in the database. And we can add some options here as well, like the max length, which we also already validate on the form here. Now we can also validate it on the model to make sure that before data is inserted in the database, we validate it again. Of course, if we're sure that we don't have any scenario where a too long string might reach this model, we can omit this. And in this case, we are sure that this will never happen because we are already validating the user input. So unless we're overriding that in our view later, then there is no way that a longer string reaches our form. So I will actually not add max length here. And we can configure it with all the options I talked about in the earlier course sections. So now here I have a username char field. I have my review text field, and that here is a text field, which is a database field for longer text. So no char field, but a text field. That's a difference to my form now. There it was a char field with a different widget. Now for the database, for the model, there is a difference. There are two different fields we can use. And for the rating, I'll use an integer field here as well. And we could again add validators for a min value and a max value if we wanted to. But again, I will rely on my input from the form. So with that, we get a model set up, a review model, which of course has some similarities to our form without the configuration here, because here, of course, we have some form specific configuration, which is related to how the form fields are being output. The model is about how data is stored in a database. That's easy to mix up, but it's a different thing. The model is not about fetching user data, but about storing data in a database. And before we fetched input via the admin interface, now we're fetching input via a user-facing interface, a custom form. So the model is again just focused on storing data in a database. Nonetheless, it is of course quite similar. And with that model set up here, we should add a max length to char field, even though we know that we never will actually insert data that is too long, but for the char field, max length is actually not just there for validation, but also for the database setup to configure that database field efficiently. So that's why I'm reminded here that we have to add it. But with that, we now set up the model, and now we can again make and run our migrations to create that database file and set up the database in there. So I'll quit this here and then simply run make migrations here. And then thereafter, run the migrate command to write those migrations into our database file and to set up this database with a reviews table with this structure. And now that this is done, we can restart our server and go to the view to use this new model to store our data instead of just printing it. So if we have valid data, now we can create a new review by instantiating this review class, which we have to import from .models. We import the review class like this, instantiate it down here like this, and then here populate the different properties, the different values of this review class, of this review model, with the values we got from our validated form. So from this cleaned data, which we printed before. For example, here, set the username, user_name, equal to form.cleanedData, and then there it's user_name as well, because in our form we have that username field name here. Set the review_text field in our model equal to form.cleanedData review text, again accessing review text on this dictionary, because that's also the field name I picked here. And we wouldn't have to use the same property names here in the review form class as we do in the model class. I did do it here also on purpose, but you don't have to use the same property names. We could use different names here in the model than we do in the form. But here I have the same names, hence we have some similarities. And now last but not least, I'll therefore set the rating keyword argument when we instantiate our review class and set this to form.cleanedData rating. Like this. Now let me add a couple of line breaks here to make this a bit easier to read. And that's now my finished review model, which is instantiated. And therefore we can then of course call review.save here. And this will now save this review model, a new review entry, to the database with that data we're extracting from our form, with that validated data to be precise. So this will only happen if the user entered valid data. And now if we save everything, if we go back to localhost 8000, if I add Maximilian here, your feedback, this was awesome. And we could change the styling of this text area as well to use the default font, by the way, if we wanted to. And give it a rating of 5, and I click send. We're on thank you, and now we don't see it here, but the data was written to the database. And of course, to see it, we can quit this development server and use the good old shell again, which we used before in this course already, to import from reviews.models. So from this models py file in the reviews app folder, our review class. And then with review.objects.all, we can see that we do have one review stored. And if I access this through its index, and if, for example, access the username, we see that this is Maximilian. So the data we entered in the form really was stored into the database. And of course, it's totally up to you what you want to do with such entered data. It's your application. But once you have it, you can do with it whatever you want. I just wanted to show you how you can get it with this forms class, with your customized form being rendered in the template, and with our view logic, where we differentiate between a post and a GET request. And for a post request, we use the form object, this built-in forms feature by Django, to validate that form and get the validated data, or send back the form with potential error messages we might have. Now there's just one last thing, one last improvement left, which will also very often help you. You might notice that in this case here, in our demo here, the form class we defined is very similar to the model class. And I did this on purpose. I even used the same property names. There are differences, for example, regarding the arguments here, Because with the form class, we specify and configure how the form is being rendered in a template, whereas with the model class, the review model class here, we specify how the data is stored in a database. Nonetheless, of course, there is a connection, because it is the data we fetch through the form which ultimately ends up in the database. Now, there's nothing wrong with the approach we took here. You can absolutely use this approach, and it's a good approach, also doesn't require a lot of code. But if you have a form which in the end just wants to fetch the user input for some model, which is a common use case as it turns out, then you can also let Django create a form based on your model. Basically, like it did it in the admin panel for us, but now not restricted to the admin panel, but to any template we want, as we're doing it here. We're not working with the admin panel in this section after all. Instead, we're talking about some user-facing forms. And you can let Django infer such forms as well. For that, in Forms PY, instead of creating my review form like this, I'll comment this out. Instead of doing this, I'll create my review form a little bit differently. And I will do that by extending forms.model form here. Before we had just .form, now it's .model form. That still creates a form object, a form class, which we can use like we did before, but we can now connect this to a model, and Django will then automatically take all the model fields and infer proper HTML inputs for those fields, and basically give us a pre-configured form based on the fields, on the properties here in our model class. For this, we need to let Django know to which model this form is related, and we do this with a nested meta class. You saw that before when I talked about models. Such a nested meta class is used by Django whenever you have a class which you want to configure as a whole. In this case, to tell Django to which model this form class should be related. And for this, in this nested meta class, you add a model property, and you set this equal to the model to which this form should be related. For this, we import from .models our review model. And it's then this review class which we set as a value here. We don't instantiate it, we just point at it, just like this. And this connects this review form to this review model. Now with that, Django will infer a form, but there is one extra field which we need to add to meta. It's very possible that you have a model where not all the model fields, the model properties, should be rendered in a form. For example, we could have an extra field in the review model where we have the owner comment, and that might be a text field where we as the owner can leave a comment, an internal comment on a review we received. And of course, that should therefore not be exposed to our end users. Now, I'll not add this here, but we could have such a field which should not be populated through the end user and which should therefore not be part of the form which is rendered. And since this is so common, Django wants you to explicitly specify which fields from your model, which properties from your model should be part of the form. You can do this by adding the fields key here and set this to a list of fields that should be included. Like, for example, user_name. And here we use the property names assigned in the class. So username, review text, and also rating. Now, if you know that you want to include all the fields you have and not just a couple of selected fields, then instead of having such a list, you can add a special identifier here, or set a special identifier as a value for fields, and that would be __all__. This tells Django that all the fields in a model, all the properties in a model, should also receive fields in the form which is rendered. except for the ID, this automatically added ID field, that will never receive a form field. Alternatively, if you know that you want to render all fields except for one maybe, you could set the exclude field and then list all the fields that should be excluded instead of specifying the fields that should be included. So here we could then render everything except for the owner comment. But here I know that I want to render all fields, so I'll set fields to all like this, and then restart my server. Now with that, if I don't change anything else in my code, if I reload localhost 8000, I get the same form as before, but now it's this review form based on the model form, which actually generates that form. Before we configured everything manually, now we're letting Django infer our form from our model. And as you see, it here infers it correctly. What you'll also notice though, is that our labels are lost. We now got auto-generated labels based on our property names here. But thankfully, we can of course still configure this form even though it's inferred automatically. And that's what we're going to do. Being able to infer a form automatically is of course great, but we typically still want to be able to configure that form to a certain extent. We might want to set our own labels or set our own error messages. And both can still be done with our model form. We can add more settings in this meta class for this. For example, a labels key. This wants a dictionary as a value then, and then we use our property names in the model, which identify these different properties and their form inputs which will be rendered, and we set our labels as the values for those keys then. So here we would add a label of user name. By the way, let me use double quotes here as well. So user name, and give this a label of your name. And for the review text, I'll add a label of your feedback. And for the rating, I'll add a text of your rating. So this special labels key allows you to still assign your own labels to the automatically inferred inputs for those model properties, for those model fields. And hence, if I reload, we now have our own labels back. We can do the same for the error texts. For this, there is the error messages key, which we can set in the meta class. And we can set this to a dictionary as well, and it then works in a similar way as the labels. We access a field by its name, like username, but then we have a nested dictionary as a value now, where we now can specify our different error identifiers and their specific error texts. Like, for example, required on the username, and then use the same error text I set up there, for example. Or for max length, and copy the error text from up there as well. So we can still configure all of that with those special labels and error messages key here in our meta class in the review form. And with that, if I save that and I then, for example, get rid of the required attribute on my name input and I try to submit this and enter something valid here, then you see your name must not be empty here. So that all still is possible and works with the model form, but we in general infer our form from the model. And it's up to you whether you prefer this approach or this approach. There is nothing wrong with managing your own form and your own model and then combining it only in the view. By the way, our view code hasn't changed, just as a side note, as of now. But we're going to work on this as well. But we can use everything as we did before and then either have our model form or use separate forms. Being able to infer our form from the model, though, could be useful because it could require less work. If we update our model, we might not need to work on our model form if it's inferred automatically. Nonetheless, let's now come back to the view function now, and let's see what we can do there with the model form. because currently we're still using it like the other form, and as you see, that works. But what else could we do with it if we wanted to? When using a model form instead of a regular form, you can change the code you write for saving data to the database a little bit. What we're currently doing in the view is we're populating our form with the submitted data, and we need to do that to then validate it. But once it is validated, we create a model instance and save that. And that works. There is nothing wrong with that. But if you're using a model form, as we are doing it now, then you actually can skip this step here. You don't need to create your model instance. Instead, you can get rid of that import altogether, and instead, after validating your form, which you should still do to potentially show that form page again with errors, but after validating this, you can simply use your form and call save on that. And that wasn't possible before. But since this is a model form, you can now call save on it, and when you do so, that will then save that data to the database through that connected model. So in this case, through that connected review model. And Django will do that behind the scenes. So it will still hit the reviews table in the database, but you now just need to call save here instead of instantiating the review model on your own, as we did it before. And that's now another argument for using such a model form, because of course this can save some extra time and code, which you don't have to write now, because we just have to call save here on this form. Now it's also worth pointing out that you cannot just call save to save a new data entry, but also to update an existing one. Here in this example, we don't update any data, we just save new data. But if we had an existing review which we would want to update with data entered by the user in a form, then we could pass an extra argument to our review form constructor and set the instance keyword argument. And set this equal to a data instance fetched from the database. What do I mean with that? Well, let's bring back that import from .models and import the review model. Once I got this imported, we could of course get access to an existing model, to make this very clear, an existing data piece in the database by using review objects get. That's what you learned earlier in the course. We could get our review with an ID of 1. Now we could then pass this existing data, which it actually is, which we fetched from the database, as a value to this instance keyword argument. And then we would still populate the form with the entered user data. Once validated and once we call save, it will then save that data, but not as a new entry, but to update this existing entry in the database. And I'm just showing this here to make it clear that updating is equally simple when using a model form as it is to enter a new data piece. For a new data entry, you simply don't set this instance keyword argument, as we're doing it here, because of course here we want to add a new entry. But updating would be easy as well. And that's another strong argument for using a model form if you do have a strong connection between a database model and a form you want to show to your users. If that strong connection exists, using a model form might be convenient, not just because your form is predefined automatically, but also because you don't have to instantiate your model in your view then. Instead, you just have to call save on the form once you validated it, and you're good to go. So that's a convenient alternative, and the model form therefore is always worth a look if you in the end just want to create a form for a model which is responsible for saving data to the database. Now, this was a lot about forms in this module, and there are always more configuration options and so on, but we learned the most important aspects in the last couple of minutes and hours. Now, I want to have another look at our view function here instead, at this review view function. Up to this point in the course, we always defined views as functions, and that is the most straightforward and simplest way of defining views. It is, however, not the only way of defining views. Instead of defining them as a function, we can also define them as a class, and that can have certain advantages. You can also mix and match it. You don't have to transform all your view functions to classes. You can instead transform the most important ones. And I want to show how we could transform this review view function to a class and why we might want to do that. For that, in the views.py file, you simply add a new class, and you can generally give it any name you want. I'll name it review view. Again, this is just some kind of convention to pick any name you want and then append it with view to make it clear that this class is there to represent a view. Then we want to extend something. And again, we want to extend something coming from Django. For that, I'll import from Django.views. I'll import, and now there's a long list of view presets we could extend. And I'll start with the most straightforward basic view. So I'll import view from Django views, and then here extend view with this review view class. Now, how does this work? It made sense that a view is a function because we want to execute code in it. How do we make this work with a class? With a class, you simply add methods to the class in which your code will execute. And when extending the built-in view class, like we're doing it here, you add methods that carry the name of HTTP methods you want to support. And that's also why we might want to switch to a class-based view. In our review view function, we had to check the request method with an if statement to compare this to post and find out if we have a post request or a get request. When building a class-based view, we can instead define methods in there which are called get and post, so which carry these HTTP method names as names, all lowercase. And Django will then automatically call the appropriate method on our behalf based on the kind of request that reaches that view. Now, in those view methods, we now should always get self, since these are methods in a class, and also accept the request, just as we do it in the view function here. And then we can execute the code we executed before. So in the case of get, I'll create my form and then return the rendered template. In the case of the post method, I now want to create my form populated with the entered data and possibly redirect if it's valid. Here, like this. Now, of course, here in post, I still also want to render my template with the pre-populated form with the potential error messages if we don't make it into this is valid if block. So I'll still render this, I'll still render my template and duplicate that logic from get. And in post, I still should accept self and the request, which we get here. And with that, we have a valid view class with our HTTP method names, where we still always need to return a response. That's the same as in the function-based view, but now we don't have the if check for the request method. And that allows us to get rid of that review function we had before. I'll still keep the thank you function, though we could also convert that to a class-based view if we wanted to. But with that, we now have this class here. Now we just need to update our code in URLs.py, and instead of pointing at views.review, we now want to point at views, review view, so this view class we just added, and call as view there. That's a built-in method, which is available because we're extending the built-in view class, and that is required here in your URL patterns to make sure that Django is able to find those get and post view methods in the end. And with that, if we save everything, if I go to localhost 8000, this is still rendered. And if I enter some data here, I can also still submit it, and everything worked as before. If I enter something invalid here, and I trick myself to being able to do that by removing the required attribute, I also still get the form with the errors. So it works as before, but now with the class-based view. And it is, of course, up to you what you prefer. I personally think that this approach, this class-based approach, is a bit cleaner since you have those dedicated methods for the different kinds of HTTP requests, which can make it a bit easier to find the code for your different request types and to maintain that code. But ultimately, as always, it of course also comes down to your personal preference and what you personally find to be the most helpful. Now, if you Google for Django class-based views, you'll find the official docs. And there, if you click on built-in class-based views, you will see that there actually are a lot of different views you can extend from. We used just the view like this, which allows us to add get and post methods. Now, there are a lot of pre-built views you can inherit from instead for specific use cases. For example, if you have a view that should be focused on rendering a list of data fetched from a database, you could inherit from the list view. Then you would add a model property to your view class and link that to the model for which the list of data should be rendered. And that would then simply be the same as if you had this view, and in the get method, you would use your model to get all the data and return your own template with that data rendered in it. That would then be basically taken care of for you. And the list view is just one example. There are other views you can inherit from as well, like a detail view for a single piece of data which you want to present. Or there is a form view, for example, with the form handling there. You have a form view where handling forms is particularly convenient. And I definitely encourage you to also dive into those dedicated view classes you can inherit, because that can lead to even less code, because you can build a view that is really focused on one specific scenario. Now, in this course section, I used the generic view because I wanted to get started with those class-based view and show you the most versatile and flexible of all those class-based views you can inherit from. In the next course section, we are going to dive into some of the other important class-based views you can inherit from, like the list view and the forms view, and we're going to see when those views could come in handy, how you use them, and why that might be worth a thought and how that can save you some time. Now that's it for this course section. This section was about forms, and specifically forms which we expose to our website visitors. We already had a look at the admin panel in an earlier course section, but the admin panel is there for us as the website owner to manage some of the data which only we should manage, like for example our blog posts or the products in an online shop. But we also often have data like reviews, feedback, comments, data like this, which of course has to be generated by the visitors of our webpage, by our users, not by us. And in such scenarios, we need to expose forms to our visitors and we need to handle them. Now, you learned how you can build a form from scratch in HTML in one of your templates, and how you can handle it from scratch in your view by manually validating it, by manually extracting the data, and by then manually using that data. Whilst that is possible and sometimes might be enough, it can be cumbersome to do that all on your own. That's why we have this form class provided by Django from which we can inherit, which allows us to build our own form class where we define our own form controls. We can give them our own labels, validation logic, and possible error messages that should be shown. And more, of course. As always, you can dive into full documentation to read about all the possible options and arguments you can pass to those controls. Now, with such a form class, we have the huge advantage that we can easily generate the HTML code that belongs to this form. We can either generate the form as a whole or individual parts of the form, like the label field, the input field itself, the errors part, and then we can really build the template as we need it, but we don't need to write all the HTML code from scratch. But that's just one of the advantages we get when using these forms as provided by Django. Another major advantage can be seen in our views. There, we now don't have to manually pull out the data and validate the data and do something with it. Instead, when using a form class inheriting from Django's form, we can just pass the received data to that form class to instantiate this class, and then we can call methods like isValid to easily validate all the data with the rules we configured when we configured the form class. That then allows us to easily render and return different responses based on the validity. And if the data is valid, we also have easy access to the cleaned data. For example, to then store that in one of our models and therefore in the database. But if that's our use case, getting data for one of our models, then we can simplify this even more. Because for this, Django gives us this model form instead of the regular form from which we can inherit. When doing that, we still get a form class which we can use, like the other form class, but we don't even need to define our controls there, our form input elements. Instead, we just tell Django which controls, which fields from our model we want to have as controls, if that should be all, or just a selected list of fields, or maybe all fields but some excluded ones. We can still configure them regarding their labels and error messages, but then we have Django infer our form controls from our model. We can then still output those form controls in a template, and when it comes to saving that data, we still validate it as we used to, but we don't have to create a new instance of our model now and pass the form data into it. Instead, we can call save on the form itself if it's based on such a model form, and that will then automatically save it to the database, either as a brand new data entry, or if we set that instance keyword argument and we point at an existing instance of our model, it will then update that model, so update that data entry in the database with the form data. And that's all very convenient and can save us a lot of time and code. And then last but not least in this section, we get started with class-based views. And I explained that you can replace your view functions with class-based views that inherit from Django's built-in view templates, so to say, view blueprints, if you want to call them like this. With that, you can, for example, inherit from the generic view to have a class where you define get and post methods, and possibly other HTTP verbs as well. And then Django will automatically call the correct method for you depending on which kind of request is reaching that view. You still point at that view in your URLs py file like this, but then if the same URL is reached with different HTTP methods, the different methods in your view will be called. And you don't have to add a if check in your view function to find out whether it's a post or a get request. So that can also make your code more structured. We're going to dig deeper into those class-based views in the next course section, but for this section we now learned about this very important forms feature, and we got started with those class-based views.